Aging is often accompanied by a paradoxical decline in immune competence and a simultaneous rise in chronic, low-grade inflammation, a phenomenon known as inflammaging. This silent, persistent inflammatory state is increasingly recognized as a major contributor to the onset and progression of age-related diseases, including cardiovascular disease, cancer, type 2 diabetes, and neurodegeneration. Yet in the midst of this general pattern, centenarians, those who live to 100 years or more, stand out as remarkable exceptions. Despite their advanced chronological age, many centenarians display immune profiles more characteristic of much younger individuals. They maintain low levels of key pro-inflammatory markers, such as interleukin-6, IL-6, tumor necrosis factor alpha, TNFA, and C-reactive protein, CRP, and show preserved function of critical immune cells, including T cells and natural killer, NK, cells. Understanding how they achieve this rare immunological balance may unlock novel strategies for promoting healthy aging. The immune system undergoes significant remodeling with age, a process known as immunosenescence. In typical aging, there is a decline in adaptive immune responses, particularly a reduction in naive T cells, an accumulation of memory and senescent T cells, and a decline in the ability to respond effectively to novel pathogens and vaccines. Simultaneously, innate immune activity becomes dysregulated, with macrophages, dendritic cells, and NK cells often shifting toward a pro-inflammatory phenotype. This dysregulation leads to a persistent elevation in cytokines like IL-6 and TNFA, contributing to tissue damage, insulin resistance, and increased vulnerability to disease. In centenarians, however, this pattern is notably altered. Studies consistently show that these individuals maintain relatively low levels of systemic inflammation, even when accounting for age and comorbidities. IL-6, a cytokine strongly associated with frailty, cardiovascular risk, and mortality, is found at lower concentrations in many centenarians than in their younger elderly counterparts. The ability to suppress or buffer against IL-6 production appears to be a defining feature of successful aging. Genetic studies have also identified variants in genes related to cytokine regulation that may be more prevalent in centenarians, suggesting an inherited component to their anti-inflammatory profile. Moreover, the adaptive immune system in centenarians shows surprising resilience. Although thymic involution and reduced T-cell output are common with aging, some centenarians retain a pool of functional naive T cells capable of mounting effective immune responses. Even more striking is the evidence that their cytotoxic T cells and NK cells maintain strong functional activity, including the ability to recognize and destroy abnormal or infected cells. This preserved cytotoxic capacity likely plays a key role in controlling latent viral infections, such as cytomegalovirus, CMV, that otherwise drive immune exhaustion and inflammation in older adults. Several mechanisms have been proposed to explain how centenarians achieve this immune equilibrium. One possibility is superior immune regulation, a finely tuned balance between pro-inflammatory and anti-inflammatory pathways. Regulatory T cells, TREGs, which help control immune activation and prevent autoimmunity, are often more abundant or functionally efficient in centenarians. Additionally, their macrophages may produce fewer inflammatory mediators in response to stimuli, potentially limiting the cascade of cytokine-driven damage. Epigenetic stability may also play a role. Inflammaging is partly driven by epigenetic drift, particularly changes in the expression of inflammation-related genes. Centenarians often exhibit more youthful epigenetic profiles in immune cells, suggesting that long-term preservation of chromatin structure and DNA methylation patterns may help prevent the overactivation of inflammatory genes. Lifestyle factors are also deeply intertwined with immune aging. Diets rich in anti-inflammatory compounds, such as omega-3 fatty acids, polyphenol, and fiber, can suppress pro-inflammatory gene expression and enhance immune function. Physical activity, even at moderate intensity, improves circulation, reduces visceral fat, a major source of inflammation, and enhances immune surveillance. Psychosocial resilience, common among centenarians, also plays a role. Chronic psychological stress is known to elevate inflammatory cytokines and impair immune function. Centenarians often report strong social ties, a sense of purpose, and emotional stability, all of which may contribute to reduced stress-related immune activation. Interestingly, centenarians do not avoid immune stress altogether. Many have experienced infections, surgeries, or systemic challenges throughout life. What seems to set them apart is their ability to recover, immunologically and systemically. This capacity for resilience, or immune remodeling, suggests that the quality and adaptability of the immune response may matter more than the mere absence of stressors. The implications of this research extend far beyond longevity itself. As populations age, the burden of inflammaging-related diseases is rising sharply. Targeting inflammation through lifestyle, pharmacological, and even immunological interventions could become a cornerstone of future aging strategies. Already, trials of anti-inflammatory drugs, senolytics, and metabolic modulators are being designed with biological aging endpoints in mind. Understanding how centenarians naturally regulate inflammation could inform the development of interventions that enhance immune resilience in the broader population. Centenarians serve as living proof that the aging immune system need not become irreversibly dysfunctional. Their ability to preserve low levels of chronic inflammation while retaining effective immune defense redefines what is possible in late-life health. By studying how they keep inflammaging in check, we move closer to strategies that do not simply treat aging-related diseases, but prevent them at their root.